Hey guys, so today we are continuing with this topic on scale. So last time we covered ratios and proportions, and now we're doing scale factors, and we will do scaling up and scaling down next week, but we will start it today. We'll just go into it in a bit more detail next week, this last part. So, overall, when we are talking about scale, just a recap, remember we are dealing with comparative relationships between elements in a design with respect to size. So, we are comparing the relationships of elements in a design with respect to size. That is what we're trying to do, which is what you guys do with the drawings, with the products that you make. So since you covered ratios and proportions, today we're doing scale factors. So just so we understand what we're talking about, let's explain first the terminology or the difference between the scale factor, and scale drawing or scale model. By definition, then, a scale would be a ratio that is between two sets of measurements, while the scale factor is the ratio of the length on a scale drawing or on a model to the corresponding length on the real object. Then, scale drawing or scale model, usually it is used to represent an object that is too large or too small to be shown or built at actual sizes. Those three definitions are important, and I put the text there so you can read them repeatedly to see that you understand. They are linked together in this way. Scale can be written as a scale factor, which is the ratio of the length or size of the scale drawing or scale model to the length of the corresponding side or part on the actual object. They are defined differently, but when we're talking about understanding the scale factor, and scale drawing, you can put them all together like that to try and understand them. So overall, all scale drawings, they have to have a scale that is written on them. You will find that in drawings, most of the time, the scale drawings have a scale written on them, and those scales will be expressed as ratios, hence scale factor. So when we talk about the scale model separately or the scale drawing, that has to have this scale written on them. The scale model is a proportional model of a three-dimensional object. Its dimensions are related to the dimensions of the actual object by the ratio called the scale factor. Hopefully, all this makes sense because I'm explaining them in different ways, linking one to the other. So try and understand it in that way. For instance, this photograph here, it shows the scale drawing of a model train. Thinking of it too small to be the actual train, but it's represented by a scale drawing, which is a proportional model of a three-dimensional object, whereby the dimensions are related to the dimensions of the actual train by a ratio of some sort that has to be specified. Cool. Moving on. The way we work with scale factors, a simpler way to think of scale factor is a new measurement divided by the old measurement. And in maths terms, we know that if you have an expression like that, you can find any one of this having been given the two measurements. For instance, old measurement multiplied by the scale factor will give the new measurement. Another way to look at it would be interlinked as new measurement, old measurement, and then scale factor. So depending on the unknown, using these three values, you can find whichever one is missing. So as a general rule of thumb, a scale factor which is more than 1 means the shape gets bigger, and that is called an enlargement or scaling up. Then if a scale factor on the other hand is less than 1, that means the shape gets smaller, or it's called a reduction or a scaling down. This is what you have to remember to work out any scale problems. So if we were to express this in maths terms, enlargement will be again using this format here, new measurement over the old one. For enlargement, it will be the big measurement divided by the smaller measurement. For scaling down or reduction, it will be the small measurement divided by the big measurement. Overall, these are the 4 steps that you need to calculate scale factor. First, you have to determine the corresponding side lengths if you're dealing with lengths. Then you have to determine whether you are making a shape larger or smaller. Then you have to determine if the scale factor is greater than or less than 1. Then if it's less than 1, it is scaling down. More than 1, greater than 1, it is an enlargement or scaling up. Then you have to write the correct ratio. So these 4 steps are important for you to remember to work out the scale factors. So if you say you were to find the unknown length, for instance, if a photograph was enlarged and made into a poster, so going from small to big, small to large. The poster then is 20.5 inches by 36 inches. The scale factor is 5 to 1. Find the size of the photograph. So what we know, what we can make out of this is that it says the photograph was enlarged, so we know it's scaling up. And then what we are given now are the new measurements, which are the measurements of the poster after you enlarge it. So that means what we're missing are the measurements of the photograph itself, which is the old measurement. So then, finding the size of the photograph, which is what we want, we will go the poster to a photograph. This is how we express it into the proportions. I'm hoping you guys are seeing the relevance of having started with the ratios and proportions, because now when we do scale factors, you need to apply that knowledge here. So poster to a photograph. This one is given, we need the photograph. We are given scale factor, which is equals to 5 to 1. Then what we do will be to express it in a proportion to find whatever length is missing. So we know now that the new measurements are 36. We start on one side because we're comparing a poster and a photograph. Let's start with the length. Starting with the length, the proportion would be, this is the long part, as you can tell, 36, that's 20. Then trying to find L, so 36 as the poster to what we don't know, which is the photograph. We put that as L. We use the scale factor 5 to 1. Then we can solve by cross multiply to find the value for L. So by cross multiply, as we did in the ratios and proportions, you will get the L. Hopefully you guys know now how to do this from the previous lecture. Then that just gives us the length of the photograph now. Now we need to find the width of the photograph. We do the same thing but using the different measurements now. Instead of 36, we use the width size. So now we know the width for the poster is 20.5. We don't know the width for the photograph, but we know the scale factor is 5 to 1. We do a similar thing, expressing it into a proportion, which would be the width 20.5 and the width of a photograph, which we don't know. We put W there using the scale factor. Again, we do cross multiply to solve for the value of W, which we get as 4.1. Now we know the size of the photograph, the length and the width, which would be 7.2 inches long and then 4.1 inch wide. So in practical terms, or in practical application, or in real life, scale is very important. For instance, you use it when objects are too small or too large to be drawn or constructed at actual size. In that way, we use the scale drawing or the scale model. Looking at this, for instance, it's unlikely, impractical to have a kitchen that is 6 centimeters. This is a kitchen setup. But because it is a scale model or a scale drawing, it will, on the scale, it will read from one point to the next, it's 6 centimeters. It's a scale model. What is the scale? Scale will be 1 centimeter equals to 1 meter. For every 1 centimeter, you equate that to 1 meter. That means the length here, in actual terms, it means 6 meters. That is more practical. And then just to say the same thing in a slightly different way, if it says the scale is 1 centimeter to 100 centimeters, that ratio means that for every 1 centimeter on the scale drawing, the length will be 100 times in real life. Another example, if you look at the map, like you have a map, the global map, as a scale drawing or it's a scale model. So if it says the ratio is 1 to 10,000, that means the real distance on a map would be 10,000 times the length of the one unit on the map. Hopefully that makes sense. So we will end this here. I just wanted to introduce this topic to you guys. And then next week, we're going to do more examples, which will be more like what you would have in the worksheet. But this was for you guys to understand this topic and see its practical applications. So hopefully you do understand, in addition to the additional resources that I gave you guys yesterday, and I'll put more next week. All right, cheers everyone.